All right. So in this unit, we are going to be talking about atoms and the periodic table. So you probably in middle school have heard about the word atoms. We are going to spend some time exploring them, not so detailedly, but I expect you to have an idea of what atoms are and in what table are they arranged. Okay. So we are going to be looking at atoms. These are the list of things I expect you to know by the time we're done with this unit. But in this specific video, I will be focusing on atoms. Uh, Atoms are ancient and empty. So we'll look at it. The pre-memorial meaning of atoms. We talk about elements. We talk about protons and neutrons, and then we will talk about the periodic table. All right. So what are atoms? Atoms are ancient. So atoms are made up of everything. The origin of most atoms goes back to the birth of universe. Mostly empty space, elements heavier than hydrogen, and much of the helium were produced in the interiors of the stars. So these elements were produced back uh, from the beginning of the universe, and it's believed that it is from the interiors of the stars that elements such as hydrogen and helium were born or were produced. And from there, the hydrogen and helium fused and gave birth to all the other elements that we have on the periodic table. All right. So, which of the following are incorrect statements about the atoms? Atoms have been around since the beginning of the universe. Atoms are mostly empty space. Atoms are perpetually moving. Atoms are manufactured in plants and in humans during pregnancy. Obviously, the last one is the incorrect statement. Okay. So, what are elements? What is an element? So an element is a material made up of only one kind of atom. And a very common example is gold. So if you see people with rings, chains, that is an element because it is pure, right? It is made up of only gold. Nothing else is added to it. So elements are pure substances that are made up of only one type of atom. Again, I might not have defined what an atom is, but an atom is actually the building block of matter, right? It's the smallest tiny particle that constitute matter. For example, your clothing, your chairs, your phones, all of them, to give the structure and the shape that you see, so many atoms came together to build that. That is why we say atoms are the building blocks of matter. All right. So atoms are the fundamental unit of an element. Okay. So the term element is used when referring to microscopic quantities. The term atom is used when discussing submicroscopic. Okay. So atoms make up all matter around us. To date, we do have about actually I need to update this. We have to date about 118. Okay. By the time this PowerPoint was made, there were only about 115 elements, but we have to date 118 elements. Okay. Uh, and then any material consisting of only one type of atom. So if you have a material that only has one type of atom, then we will say it's an element. So now let's now go inside the atom. Okay. Now, if you have an atom, what is an atom made up of? An atom is made up of protons. So we have protons in the nucleus of an atom. So at the center of every atom, there's a core right there that we call a proton, that we call a nucleus. Now, inside the nucleus, we have protons, and these protons, they carry a positive charge. Okay, so they have a positive charge and it's the same quantity of charge just like the electrons, which we're going to see later. And they are about 1800 times more massive than the electron. So the electron has almost no mass, but the proton are about 1800 times more massive than the electron. And they have the same the same number of protons in the nucleus as the electrons. So every atom has the same number of proton as it has electron. Every atom. Okay. Now let's look at the electrons. Again, the electrons are identical. Uh, uh, they repel one another. Okay, and so electrons, remember, they are also in the atom. Okay, and they have a negative charge. They are not in the nucleus, which means they are not in the center. They are actually in the periphery of the nucleus. This periphery is what we call the shells. We will look at them very soon. By the time we've done so many other subunits in this chapter, we talk about where the electrons are located. All right. So let me introduce you now to another concept that we call the atomic number. So what is the atomic number? The atomic number is defined as the number of protons in each element. Okay, it is actually the basis that we use to arrange the elements in the periodic table that we are going to see very soon. So the number of protons in each atom is what we call its atomic number, and every element has different atomic number. Now, in addition, in the nucleus, we have neutrons. Okay, neutrons, they accompany the protons in the nucleus. So in the nucleus, you have protons and you have neutrons. And these neutrons, they have the same charge like the protons. Okay, they have the same charge like the proton, but they are electrically neutral. They have no charge. Okay, now there is a term that we call nucleons right here. So protons and neutrons are collectively called nucleons. So if you see this word nucleons, it means protons and neutrons. All right. Now, let's talk about isotopes and atomic mass. What are isotopes? Okay. So remember I told you that neutrons are found in the nucleus of the atom. So sometimes you have different versions of the same element. So you can have a same element, and then how do you know it's the same element? The number of protons. The number of protons identify each element. So you can have an element with 10 protons. So long as it has 10 protons, that element is called neon. Now, you can have neon having different type of a different number of neutrons. So you can have a neon with 11 neutron and you have another neon with 12 protons. With 12 neutrons. Elements that have different neutron number are called isotope. So it refers to atoms of the same element that contain the same number of protons but different number of neutrons. Okay, so just remember that that isotopes are atoms of the same element. They have the same number of protons but different number of neutrons. And so it they are identified by the mass number, okay, which we are going to learn very soon, which is the total number of protons and neutrons. The mass number, if you want to know the mass number, you add the number of protons plus the number of neutrons. So if in a nucleus you have 5 protons and 5 neutrons, then the mass number is 5 protons plus 5 neutrons, which is 10. Okay, and so isotopes, they differ only in mass and not by electric charge. The only thing that isotopes have that's different is that they have different mass number. Okay, so take note of this one right here. The total number of neutrons in an isotope is equal to the mass number minus the atomic number. All right, so now let's talk about the atomic mass. Is the total mass of the atom, right? The total mass, which means the mass of the proton, the mass of the neutron, the mass of the electron. So just think about an atom like a bag, and in the bag you guys have your lipstick, you have your money, you have some quarters, you have some pennies, you have some dimes, all of that in the bag. If I want to know what the mass of the bag is, I just need to know the mass of everything in the bag. So it's the same thing. So if you want to know the atomic mass is going to be the mass of everything that's in the atom. We have protons in the atom, we have neutrons in the atom, we have electrons. Okay? And so that is the mass that is listed in the periodic table, right, as the atomic mass. And we are going to look at that very soon. So we have a unit that we use in measuring mass. Just like you measure mass in pounds, we have a unit that we use in measuring the mass of the atom, and that's called the atomic mass unit. and 1 atomic mass unit is equal to 1.66 times 10 to the 24 grams, or 1.66 times 10 to the 27 kilogram. All right, let's check for understanding. The atomic number of an element matches the number of, again, remember, I told you the atomic mass matches the number of protons, okay, in the nucleus of an atom. It also matches the number of electrons, because remember I told you the number of protons and electrons are always equal. So you can say that the atomic number is the number of protons in an atom, or is the number of electrons in a neutral atom, okay? A nucleus with an atomic number of 44 and a mass of 100 must, again, how do we calculate the number of neutrons? We take the mass number minus the atomic number. So if you take 100 minus 44, you should get the number of neutrons, which is 56. So remember that formula. I hope you wrote it down. The mass number minus the atomic number gives you the number of protons. All right, so that's that for now. In the next video, we are going to look at the periodic table.